Okay, so let's unpack this. We have a lot of great material here on the functional skeleton of Kubernetes. Our mission today is to really extract the architectural nuts and bolts you need to know, not just for, passing an interview, but for actually designing scalable apps and debugging things when they go wrong in production.
That knowledge is so foundational. At its heart, Kubernetes uses a pretty clear master worker architecture. You've got the control plane, that's the brain, making all the big decisions for the cluster. And then you have the worker nodes. That's where your applications actually live and run.
Let's focus on the control plane first then, the brain. So where do the instructions, the commands, where do they all go in? What's the entry point?
That would be the API server, the kubeapp server. Think of it as the front door for the entire cluster. Every command, whether it's from kubeecho or a UI, it all has to go through the API server. It validates the request and then updates the cluster state.
Okay, so it's the communication hub. But where is that state actually stored? What's the single source of truth?
Right, that's et cetera. And et cetera is absolutely critical. It's a key value store that holds the entire configuration and state of the cluster.
The entire thing.
Everything. Node details, secrets, deployments, all of it. If you lose et cetera, you lose the state of your cluster. It's probably the most sensitive component.
Wow, okay. So what about the automated parts, the things that keep the system running smoothly? How do they work with that state?
They interact by watching the API server. The controller manager is key here. It's basically running a bunch of background loops, these controllers, and they're constantly checking
Checking
the desired state, what you asked for, against the actual current state of the cluster.
and fixing any differences.
Exactly. You ask for 3 replicas of your app, the replica set controller, make sure you always have 3 running. That's its job.
And before any of that happens, something has to decide which node a workload should even run on.
That's the scheduler, the kube scheduler.
Right. And what's the main input for its decisions?
Mostly resource availability. It looks at CPU, memory, and the current load on each node to find the most optimal placement for a new pod. It's all about efficient resource use.
Okay, so the control plane decides what and where. Now let's shift to the worker nodes where the execution happens. What's the local agent there carrying out these orders?
That would be the kubelet. There's a kubelet running on every single node in the cluster. It talks to the API server, reports on the node's health, and it's the executor. Make sure the containers defined in a pod are actually running.
And this is an important distinction, right? Kubelet gives the instructions, but it doesn't run the containers itself. It delegates that.
Precisely. Kubernetes itself doesn't run containers directly. It relies on a container runtime like Docker, or more commonly now, containered, to do the low-level work of starting and stopping the containers.
That abstraction is key.
It is. And that brings us to the most fundamental unit, which can be a bit tricky, the pod. A pod is the smallest thing you can deploy. And the real insight here is that containers live inside a pod. And all containers in one pod share the same network, the same IP address.
Which enables all those powerful patterns like sidecar proxies. That shared network is what makes it all work. So let's bring this back to the real world for our listeners. Let's say you're running a big e-commerce site. Why does the relationship between the controller manager and the API server matter to you?
Because that's how you get reliability. It's self-healing. Think about a rolling update for your website. You can deploy a new version with 0 downtime because the controller manager is carefully bringing up new pods and only terminating the old ones when the new ones are healthy.
And the scheduler is placing them on the best nodes.
Exactly. And if a whole server goes down, the controller manager sees that mismatch. It expected pods to be running there, and now they're not. So it automatically creates new ones, and the scheduler places them on healthy nodes.
And if you understand that cycle, you can define better resource requests and limits for your pods, which the scheduler uses, and that can save a lot of money on infrastructure.
It's fascinating when you realize Kubernetes isn't just a tool to run containers. It's really a distributed state machine. Mastering it isn't about memorizing acronyms. It's about internalizing that feedback loop.
Right. It's not just a list of components. It's a dynamic system. So if you're learning Kubernetes seriously, practice plus concepts equals mastery.